Day 196 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 196 and we're still going strong, y'all, with no signs of slowing down anytime soon. And I hope y'all feel the same way. Today we're going to do another hard problem. We're in the middle of the top interview 150 or the top 150 interview LeetCode problems. We're doing those and we've come across another hard one, y'all, and we're not going to let that deter us. We're going to do it and we're going to get through it, y'all. This is our second hard problem, but I think after all of the knowledge and all the progress we've made so far, I think we can handle it, y'all. And I think y'all can handle it too, especially if you've been keeping up with this channel. So before we get started today, though, don't forget, y'all, if you guys need any Apple AirPod headphones, go ahead and click that link in the description and go ahead and get you some. And then after you do that, go ahead and bring a mouse right over here. Right over here, right over here, and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we could run up this engagement and we could push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow. And one way we can do that is to share this content out with as many people as we could find that will watch it. So your support is appreciated when it comes to that, y'all, because you already know Swift is the new Python. Now, with all that being said, y'all, I know why y'all here, so let's get started. And today we have question number 42, trapping rainwater. The difficulty level is hard, but don't worry. We're going to keep the solution as simple and easy to understand because we're all here to learn something and we're all here on different levels of our programming journey, and we want to come up with a solution that anybody will be able to understand no matter where you are on your programming journey, y'all. So get excited about that. Now, let's see what the question says. It says, given an n non-negative integers representing an elevation map where the width of each bar is 1, compute how much rainwater can trap after compute how much rainwater it can trap after raining. So let's break that down. Let's look at example 1, see what they're talking about. They have a nice picture for us to look at to help us understand what it is that they want us to do. So let's see. In example 1, we have the input height equals an array of integers 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1. The output is 6. Explanation says the above elevation map, the black section, is represented by the array 0, 1, 0, 2, 1, 0, 1, 3, 2, 1, 2, and 1. In this case, 6 units of rainwater, the blue section, are being trapped. So let's see what they mean. Let's break that down, right? So this right here, this array of integers, the input height represents the black section of what we're looking at, right? So first we have 0, boom. That's why there's nothing right here. It's 0, boom. Then we come over, we have 1. You see there's only 1 bar right here, or the height is 1, right? Then we come right here, 0, 0. It's nothing right here. Then we come right here, 2. Now you see right here the height is 2. It goes 1, 2. Then we come over, boom, back to 1. We have a 1 right there. The height is 1. Then we have a 0. It's nothing right there. Then we come right here. Height is 1 again. Then we come right here. This time the height is 3. It comes all the way up here. Then right here we have a height of 2 right here. Then we have right here we have a height of 1. Then we have another height of 2 right here and a height of 1 right here. Now that's the black part. That's represents the elevation map, right? So what we want to do is see how much rainwater we can collect with this input and the elevation map heights that we have, right? So the blue part represents the rainwater. So if you look, the output is 6 because we could collect 6 units of rainwater, right? So right here, the height of rainwater is 1. You might notice right here, it's empty, but there's no rainwater. And that's because since this is the first index, we could assume everything to the left of this is like just an open sea or something. It's nothing right there to really contain the water. So it's just going to keep flowing at sea level. You know what I'm saying? Once we get right here, it's more of in a container so it could fill up. But right here, since it's right at the beginning, there's nothing to fill it up with. It's just going to keep draining out. Whereas over here, it won't be able to drain out. And over here, it won't be able to drain out. And over here, it won't be able to drain out. And you notice over here, once again, it could drain out this way. It could drain out this way. Right here, it could drain out this way. So as we continue to move forward, we see right here we could trap 1 unit of rainwater, right? Because this height is 1, so anything else is going to drain out. If we say if it was 2 units of rainwater, the second unit would just drain out. It would flow over this and come over this. So right here we could collect 1 unit of rainwater. Right here we could collect 1. Then right here we could collect 2, 3, and right here we could collect 4. No, excuse me. It'd be right here would be 1. Then over here we could collect 2, 3, 4, 5. So we could collect 3 or 4. We could collect 4 units right here. Boom. This would be 4 units of rainwater that we could collect. We could collect 1 right here. Then this would have a height of 2, so we could collect 2 right here. That'd be 3. Then we can collect 1 more right here, making it 4. And in total, so far, we've collected 5 units of rainwater. Then we come over here. We collect our last unit of rainwater in this example, which would make it 6 units of rainwater that we could collect, which is why the output is 6. And if you pay attention, you'll realize that these each represent each one of these blue squares. You can imagine it like right here and right here. Then this would be a square right here. Represents 1 unit towards the output, right? And since there are 6 units right here, that's why the output would be 6. It'd be 1, 2, 3, 4, 5, and 6. So that's how we got 6. Now let's look at example 2. It's the same thing, except we don't really have a picture to look at, but we could go through it anyway. In example 2, we have the height, which is an array of integers, 4, 2, 0, 3, 2, and 5. This time the output would be 9, and it would follow the same rules or the same requirements, the same parameters as example 1, basically, where it's like if you could imagine this one, it would be up here. This would be 4. We'd have 4 units right here on our elevation map. Then we'd have 2 right here. Then we'd have 0 right here. Then we'd have 3 right here. Then we'd have 2. Then we'd have 5, right? And the output would end up being 9 in that scenario. So now that we understand the question, let's get into the fun part, the part we all know and love, the part that keeps us waking up in the morning, keeps us motivated, the actual code. And the code is not even that difficult. It's not that lengthy either, so let's get into it. First thing we are going to do is we are going to declare a variable called left. We're going to set that equal to 0. Then we're going to declare another variable called right. We're going to set that equal to height.count minus 1. Then we're going to declare another variable called left max. We're going to set that equal to height, square brackets, left. Then we're going to do the same thing, declare another variable called right max, set that equal to height, square bracket, right. Then we're going to come down here, declare another variable called trapped water, set that equal to 0. Then we're going to come right here, we're going to say while left is less than right. We're going to open up the brackets. We're going to say if height, square bracket left, is less than height, square bracket right, then what we're going to do, we're going to open up the brackets, but we're going to open up the brackets outside of that square bracket, right? And we are going to say left max equals max, open up the parentheses, left max height, square bracket left. Then we're going to come underneath that and we're going to say trapped water plus equals left max minus height, square bracket left. And after that, we're going to come down here. We're going to increment left by saying left plus equals 1. Then we're going to come right here. We're going to say else. Open up the brackets. We're going to say right max equals max parentheses right max comma height square bracket right. Then we're going to come underneath that and we're going to say trapped water plus equals right max minus height square bracket right. Then we're going to come underneath that and we're going to say right minus equals 1. Then we're just going to come down here outside of the while loop and we are going to say return trapped water. And that should be all she wrote, y'all. Should not be that. That should be all she wrote. Let's run it. See how it runs. Make sure it runs properly like it's supposed to. And it's accepted, y'all. Look at that. So let's submit it. Make sure it stays accepted. Let's see. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. That's what I'm talking about. That's what I like to see. That's what I like to see, y'all. And you know what else I like to see? I like to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.